So in this video, we're going to solve this problem where we're told household bleach, otherwise known as sodium hypochlorite, formula here, has a concentration of 0.55 molar, and it has a Kb of 2.85 times 10 to the negative 7th. And we're asked to calculate the pH of the solution. So again, what we're calculating is the pH. So we're going to start off with a balanced chemical equation, and our hint here is we're given a Kb. So that's a sign that this is a weak base. We hopefully already also can figure that out from our formula. So we can start off with our weak base equilibrium, where we have NaOCl aqueous plus water in the liquid state goes to, in this case, since we started the weak base, we're going to end up with hydroxide, OH minus, plus our HOCl aqueous, and then we also have our spectator ion, sodium ions. Okay, we're going to solve this using our an ice table, and so we can go ahead and set this up. Initial change equilibrium, and we're told we initially have 0.55 molar. Water we don't care about. We have no hydroxide, no HOCl to start, and sodium we don't care about. So our change on the reactant side, we're going to lose something, so minus X, and everything's 1-to-1 ratio. So on the product side, we have X and X. We can add things together. So our change is 0.55 minus X, X, and X. And now we can set up our Kb expression. We know Kb is equal to our concentration of hydroxide times the concentration of HOCl divided by the concentration of NaOCl. And we also know that this is equal to 2.85 times 10 to the negative 7th. And we can now substitute in our equilibrium expressions. And so that's equal to x squared over 0.55 minus x. And this is the expression we're going to have to solve for x. But before we do that, let's just back up and think about how we're going to get to pH. And if we go back up to our ice table, what's important to recognize here is that we have defined X to be the concentration of hydroxide at equilibrium. And so what we're going to want to do is we can see that X is going to be equal to the concentration of hydroxide. So if we can solve for X, we can find the pOH from the negative log of hydroxide. And if we know the pOH, we can find the pH from 14 minus the pOH. So that's our process to find the pH of our solution. But first, we need to solve for X. And in order to do that, we're going to solve our expression. And what we can do is make our assumption. So again, we're going to assume that 0.55 is much bigger than X. By making that assumption, we can simplify our expression. You don't have to do this, but it makes our lives a little bit easier by avoiding the quadratic. So x squared over 0.55. So now we can solve for x. I'll pull up my calculator. So we have, let's clear that. We have 2.85 times 10 to the negative 5th, seventh. We're going to multiply that by 0.55 equals. We then take the square root of our answer, and we can see that x is going to be 0.0000396. So we've made an assumption, so we should check it. We're going to check our assumption. And so we're going to take our ratio, we're going to take that x 0.00396, we're going to divide it by 0.55, multiply it by 100 to turn it into a percentage, and as long as this is less than 5%, our assumption is valid. So we have 0.000396, so we're going to divide that by 0.55 equals times 100 equals 0.072, so that's less than 5%. So we can say our assumption is valid. Okay. So we now know what X is, and we said X is the concentration of hydroxide. So now we can come down and solve for our POH, which equals negative log of our hydroxide concentration, which we now know to be 0.000396. We can find the POH, and I'll pull up the calculator again. We get negative log 0.000396 equals, and the POH equals 3.40. So to find the pH, we're going to do 14 minus 3.4, and the pH is going to be, so 14 minus 3.4 equals 10.6, which again we can do the check to say, does our answer make sense? We have a pH of 10.6, that's a basic solution. And what did we start with? We started with a weak base, forming hydroxide, so that should make sense. Thank you.